Hi there, welcome. We're just going to give it a couple of minutes, I think, just to wait to see if some more people join. But welcome to Titan's Safe and Resilient Infrastructure webinar this morning. My name's Sarah Hardy. I am the Marketing Director for the Federated Telecoms Hubs. I'm just going to go over a couple of housekeeping points before I hand over to Titan Director, Professor Harold Hass. So just to note that the session is recorded, so if you don't wish to be recorded, please just keep your cameras off. If you could also stay muted during the sessions, that would be great. Finally, just to add that we really want this to be an interactive session, so we ask that during the panel discussion that you add your questions in the chat and put your hand up and interact with the polls. There'll be various polls throughout the session this morning as well. So with that, I would like to hand over to Titan Director, Professor Harold Hass at the University of Cambridge. Thank you.
Thank you, Sarah, and good morning, everybody, for our new webinar series we've created around the accelerators within Titan. So my name is Harold Hass. I am the Titan Director, as Sarah said. So Titan, just to remind us, is the one of the four hubs on network of networks. We have in total 20 partners, 16 universities, and 4 research institutions in Titan. And as our title says, we are trying to advance new technologies that underpin the ultimate network of networks. And it's important, I suppose, going forward when we look into a world of the future. And just coming back from a seminar at EPSRC, where we were asked to provide some views on how the world could look like in 2050. And I think what we are seeing is the emergence of more autonomous systems like driverless cars. We will see more drones and all sorts of devices that really need machine-to-machine communication capability. We also need, as a big challenge, creating ubiquitous networks, so networks that provide coverage everywhere at a very solid way in terms of coverage, but it is also important, if you look forward, that the networks become more resilient. So we can't tolerate, if you have machines that communicate with each other, that you have long outages, as we have sometimes with Wi-Fi, because that may pose a security risk or a failure in a system operation. And also we want, if you have more autonomous systems like driverless cars, we don't want to have anyone to tamper with the operations within a car to turn them into weapons. So in that context of these new devices coming in, resilience and security and safety are really themes that should not be afterthoughts. They should be really embedded in the design of the future networks. And this is particularly important in a context, for example, of non-terrestrial networks, which fill that gap of sort of connectivity, where we design new waveforms. And the question is, can we design new waveforms that are a priori, by design, more resilient and also more secure? And we have also many stakeholders as a hub we want to serve, and therefore I'm really delighted today that we have a very fine alignment of keynote speaker and panelists in the seminar, where the idea really is to connect our research within the hubs with the industry needs. And that's one of the driving forces. We want to hear from our industry partners what their priorities are. We want to understand how we can align our current research program within Titan towards fine-tuning it to actual real needs in industry, in industrial settings. So it is an absolute pleasure, therefore, to maybe introduce our keynote speaker, which is Dr. Henrik Almeida, from Ericsson Research. Ericsson, as you know, have just recently established their research labs in the UK and are expanding their operations, their research operations in the UK. And it's really wonderful to be able to have Henrik joining us and provide us with his view in terms of where the research should go in order to build more safe and resilient networks. Over to you, Henrik.
Thank you very much for that kind introduction, Harald. It is my pleasure to be here, and I'm very happy that you provided me the opportunity. So thank you for that. And also, I'm honored to speak to you in the audience. Thank you. So I thought I would see if I can share my screen with you to share some content. I just before the meeting started, I felt out because my phone got overheated. I'm calling from Sweden. We have very hot weather, and the phone got overheated, and it was just shut out. I started a new phone, and hopefully this will work. Can you see my slides now? Thank you. Perfect. So let's see. Loading here a bit. Right. So I thought I will talk you through some of the things that we as a system vendor consider important when it comes to future networks, network evolution, and network research, and also some specifics with regards to security. I have 20 minutes. I will walk you through the slides. The slides are more just to have something to look at. I will hopefully speak you through. But just before that, something short about myself. And important to know is just that I've been around for quite some time, 27 years at Ericsson. Yeah, so that's actually, I've been 27 years at Ericsson Research and 35 years at Ericsson, all in all. So that's quite a lot. Now, since 2023, I'm trying to establish a research center here in London, doing 6G research, focused on radio access networks, but also on hardware security. And it's under construction, you could say. We are building up and employing people slowly, but still moving towards, I have a slide on that anyhow, hopefully 20 researchers all in all. So what I wanted to speak about today then is the following. I need to tell you something about Ericsson, and I'm sorry if some of you may have seen some of these slides before. Just some general slides shortly about Ericsson. I would like to talk about innovation, affordability, importance of that, something about network evolution of 6G, and then I will end up with some hardware-oriented security questions that we consider important. And then finally some short conclusions. So that's more or less it. Please interrupt me if there are any questions or something that you are wondering about. So Ericsson, quite a large company, around 100,000 employees. Important here maybe is the patent portfolio, which is of course the way for us to be able to be part and compete with other big companies that are trying to develop and sell wireless 3GPP infrastructure, radio infrastructure and networks. Innovation is key here. Ericsson is not competing on price. We cannot do that. Our employees are mainly, it's all around the world, but still cost for employment is quite high, and we try to compete, and also has always been trying to compete on quality and performance rather than the price. So innovation is therefore key. Without innovation, we cannot compete on performance or quality of our products. So innovation is important. Our vision is limitless connectivity, improving lives, redefines business, and pioneers sustainable future. And hopefully we will see that sometime. Going into research, Ericsson Research is a kind of research institution within Ericsson, which is a global, has global operations. We are spread out around the world. Of course, big part of it in Sweden, where we have at least 5 sites. But then we have sites all over, and now lately we also opened up one in the UK, which is very nice. And the sites of the site in the UK is fairly big, because we expect to be around 20 researchers all in all. 2 teams with 2 researchers in each, and the focus of these teams will be to do research in the networks area, specifically radio access network area, but also in the security area with the other team, and focused on hardware security. I will not go through the details here, maybe because of time, so I will save that. If you have questions, then just ask me. Something about the output of what we do at Ericsson Research. We try to provide a scientific contribution in the ecosystem wherever we are around the world, and hopefully we will be able to do that also here in the UK. But besides that, of course, we are also trying to provide commercial impact through our patents, standard contributions, and the knowledge transfer that we do to our R&D departments. I think it's important because we say that we are dependent on innovation, but it's important to understand that there is a lot of things that can be good ideas and even patentable, but not everything turns into innovation. So I'll try to define what the meaning of innovation, and of course it has to be a novel idea, concept, technology, which then possibly can be protected, but also it's imperatively important that there is a market need and that it is affordable on the market. Without that, it doesn't become an innovation in the way we see it, at least. So affordability and market need is as important as the novelty. That's more or less what I'm saying here. And affordability, one way of making it affordable is, of course, global standard, especially when it comes to communication, which are dependent. It's a large system dependent on its interfaces and the performance of these interfaces. So global standards are important. Of course, the radio interface connecting to any of the devices that you are using, but also all of the other interfaces that are standardized in 3GPP and other standardization fora. It ensures compatibility, interoperability, provides some kind of minimum requirements, broader market and higher volumes, of course, and lowers industrialization costs. So this is very important for us, and we are striving to achieve global standards with our solutions. Going into network evolution, then what we think is that, of course, that we want to see a stepwise technology adoption on the market, driven by network demand and monetization opportunities. Comes back again to affordability. Because anything else will just kill the market, and we don't want to see that. We still think the market is strong. I mean, I don't think any one of us can consider a future without having a phone, a mobile phone, meaning mobility, being able to move around and have full connectivity wherever we are. But also then we think that 6G should be built on 5G advanced, providing a smooth migration path, including then spectrum sharing between 5G and 6G, And we think that's key also to enable 6G coming up, the new standards. Right. 6 drivers that we see for the moment. Cost optimization in general, important, of course, again, falling back to affordability. Energy performance, of course, very important. We think there will be several new capabilities,
This is all about
like
6G
sensing.
That's why I sort of wanted to listen in.
Sorry?
Sorry, can we ask everyone to mute themselves, please?
So there will be new network capabilities and of course a lot of new type of devices for whatever extended reality or other type of devices. We think there is room for more uplink capacity and more efficient spectrum utilization. Still, with regards to spectrum utilization, we think there is a shortfall of about 1.5 to 2.2 gigahertz only for the 6G use cases in about 2030. So that is also an important point for us. Moving then into the vision of the future, as you can see, let me put a pointer on here, maybe. Yes, I hope you can see my pointer. We have the connectivity platform that we are developing down here with a lot of new capabilities up here and enabling new services up here and interconnecting a digital reality, meaning a digital environment where we have digitalized everything digitally represented more or less in our physical world, which is over here, and then we can interconnect this with the network. But then in the platform, you can see that it has to be an intelligent, it has to have efficient cloud environments for compute capabilities. It has to be trustworthy and with limitless connectivity, hopefully, this platform. And then if we look then at the trustworthiness, then I've compiled 5 questions which we think are important for the future. And note, please, that I'm not an expert in this field of security, trustworthy, although I have been working in this area for a certain period of time. So, the questions that we see important, hardware-oriented questions that we see important in the future are the following. We think there will be a practical problem or certificate management in the core network, especially assuming a service-based architecture. So one question would then be, how can we make this scalable, both up and down, based on the microservices being started or closed? So that's one question. Move on to the next one. Security of memories and a secure hardware architecture in general. How can we improve memory protection against different problems like buffer overflow attacks or similar kind of pointer issues? In the UK, you have developed to a great extent, actually in Cambridge, Harald, you developed the Sherry architecture, which is very interesting or robust. But so far, it's not adopted on the market. And this, we think, overall, this area is very important for us. We want also to be able to dynamically allocate hardware resources to any execution environment. And that, of course, requires that we can connect safely to any hardware that we have in our systems. Another thing is improved enclave support. We are thinking of if it will be possible to get some kind of hardware abstraction layer with access to common libraries for basic functions, supported by any of this big CPU architectures or vendors. We think that would simplify for us a lot. And is that possible? And then, yes, when it comes to enclaves, there are some expectations and also regulatory requirements to monitor containers or enclaves in real time. And then we could get into issues with what we are exposing. So we are considering if we could have some kind of nested enclaves providing required monitoring functions in a more granular way to avoid unwanted exposure. So we would not like to expose encryption keys, for example, things like that. And finally, buses between different chips. There is a need for encryption there, and we would like to see some lightweight encryption, which makes the work when it comes to buses between different chipsets or chips. That's the 5 security questions that I would like to highlight. And then finally, then just something about what I just talked about. Let's see if I can get this to work. Sorry. Why doesn't the text pop up? That's strange. No, sorry. So 6G research is accelerating and 6G standardization is upcoming. Affordable innovation and smooth migration utilizing the full potential of 5G systems will take us to a successful 6G. 6G takes a step further in enabling a cyber-physical continuum, and novel security solutions may become a key enabler in 6G systems. Or maybe I should say a necessity for these future systems. That's more or less what I had for today. Are there any questions?
Yeah, thank you so much. We've had a couple of comments in the chat. I don't know if we don't have a lot of time, but I'll probably relay what the conversation. You might want to comment on that. So John Goodacre from Innovate UK said it's surprising not to see security and resilience in the priority list on slide 13. And then there was a response from Alexander Hamilton from Nokia, who said security and resilience are indeed priorities as part of 3GPP for 6G, but the details of which will be ironed out. And there's a few more comments. So Rob Maunders already also said, sorry, to what extent does Ericsson expect 6G to be a software update to 5G equipment? So I don't know if there are a couple of comments that you'd like to respond to.
Okay, I will have to look back on these questions. Now, there was several you mentioned. One of which I catched was that you didn't see security here in this one, right? This is what I understood.
Yeah, that's it.
Which definitely it could be written in here. I mean, we have it here in the way we describe 6G as one of the pillars. So definitely that is something that needs to be in place. So I think that for the other slide, this one is more just pointing out some technical areas where we think there is great improvement potential. So there's nothing about down prioritizing security or anything like that. It's just that I will consider that and maybe add it to the next slide. Thank you.
Thank you. And then there was the comment from Rob Maunder that was asking, to what extent does Ericsson expect 6G to be a software update to 5G equipment?
Not really, I would say, because we will have 5G, we will have 5G Advanced. So the point with 6G will be that we will be able to offer new services. And I believe that many of these new services will be dependent on new spectrum. And then it's not just the software upgrade. So that would be my response to that question.
Rob, do you have a response to that? Or I think Bridget's commented in the chat, 6G, in my view, is no longer about uplifting 5G mobile technology. It's about convergence of underlying technology into a single coherent communications infrastructure across mobile, fixed and NTN. So I don't know if that's probably the final comment, I think, because we're running a little bit over, but if you want to respond to that, Henrik.
But definitely we will see coexistence between different systems, but we also need to, I don't think it's a difficult question to answer simply and short, but I think it takes some work if we want to see a merge between different technologies and different systems. It's not that easy because they have quite different properties, these systems. So we'll see, but hopefully we can see something with regards to NTN. I hope so. But then, yeah, it's a matter of spectrum, matter of quality of service, mobility, all kind of things that we take maybe for granted in the mobile systems today, but which need to be in place to be able to see some. And then if that happens, then is there a different system then or what? Is there a merger of systems, or is it really that everything is converting to one solution? Yeah. So I don't know if that answered your question or not, but.
That's great, thank you. Well, on behalf of Titan, I'd like to thank you very much for your talk, Henrik. And we will move on to our next session now, which is the research showcase. So this is a really quite compact session. We've got 9 presentations there, 2 minutes each. So these are quite fast paced. So if I can please ask Professor Popular, please, to begin his presentation from the University of Edinburgh.
Okay, just a minute, trying to share my screen. I believe my screen is sharing now.
There we go. Yes, that's great. Thank you so much.
Excellent. Good morning, everyone. It's been a pleasure to be in this webinar. It's been very interesting so far. So my name is Popular from Edinburgh University, and I will be talking for about 2 minutes on the work we do on underwater optical wireless communications within Titan. So the first question is, what is the problem statement? What problem are we trying to solve? Why are we interested in underwater optical wireless comms? So the simple answer to that is, if you look at the modern economy, we have underwater infrastructure and facilities, and those are the mainstay of modern economies. For example, gas pipelines, power cables under the sea, offshore wind energy, and a lot more infrastructure, not to mention oil and gas exploration. All of these facilities, they will require communication and sensing for their continuous monitoring. We want to monitor what is going on with this infrastructure so that we can have a safe operation, minimize risk, and maximize output in certain cases. We recently have been hearing about a lot of issues with underwater cables and the tension that is raising in different countries. So it is vital, to have this system that we can communicate safely in underwater. And beyond those infrastructure, we also have applications in things like environmental monitoring, climate emergency, national security, and so on and so forth. So those are the key reasons why we need to have safe and secure communication underwater. So if we look at how that is done at the minute for facility monitoring in particular, it basically depends on using tethered remotely operated vehicles. Because of the cable, these are not very flexible and not easy to use around complex infrastructure. Other option might be to use autonomous underwater vehicle. Again, these have no cables, but you cannot in real time update the control mission. You cannot stream images, for example, to the shore to control the operation that you do. And the techniques for operating underwater wirelessly at the minute for communication is dominated by acoustics. But there's a huge problem there because acoustics has very low speed. We're talking of kilobits per second. The distance can be very long, but the speed is a bottleneck. So streaming a video of a facility you want to measure can become a problem. Sarah, you've got your hand up.
Yeah, it was just a 30-second warning.
That's
Those 2
fine.
minutes go quickly.
That's fine. So, and then we have radio frequency and all of their limitations are stated there. But within Titans, what we are looking at is, first of all, to design an underwater optical wireless communication system that is resilient through waveform design, and then move on to a multimodal integration. In other words, to combine all these different bearers and in a synergetic way that we kind of use all of the advantages to have a resilient and safe underwater wireless communications. Thank you.
That's great. Thank you so much. So next up, we have Professor Raj Bhandari from the University of Strathclyde.
Hello, everyone. It's my pleasure to be here, and thank you for invitation. I'm Susan Raj Bhandari, working in the area of optical wireless communication at the University of Strathclyde. And I'll be talking about solar blind ultraviolet micro LED optical wireless communication. So you have already seen one application of optical wireless communication for underwater, but I'll more especially talk about terrestrial and non-terrestrial network. Especially wireless communication, as you know, is a backbone for UK digital infrastructure for next generation network. As we move towards the 6G network, where we talk about non-terrestrial coverage, connecting platform in land, air, we already see and space, the existing technology has certain shortfall. Especially they have to operate in the complex and unpredictable environment where the current wireless communication fails or very unreliable due to interference or high background noise. So here as a solution within Titan, we are looking into the optical wireless communication using ultraviolet LEDs or ultraviolet source. The reason that is interesting is that because there is no solar background, that means we can operate in almost no ambient light noise condition. Also, because of the wavelength, smaller wavelength, we can have compact, low power, and cost-effective solution. At Institute of Photonics, University of Strathclyde, we are developing ultraviolet optical wireless communication demonstrator that can work or provide the data rate exceeding 5 gigabits per second over a long distance, 10 meter or beyond. At the same time, we expect it to have at least 5 times lower swap than existing RF communication. Such demonstrator or proof of concept UV can provide reliable, high-speed communication in challenging environments such as drone or HAPS or even in disaster response cases. With this innovation and in combination with other innovation within Titan or other communication hub, we expect to build a robust, ubiquitous communication network for the future. Thank you.
That's great. Thank you so much. So next up we have Professor Petropoulos from the University of Southampton.
Thanks very much, Sarah. My name is Perikis Petropoulos. I'm with the Optoelectronics Research Center at the University of Southampton. And within Titan, I'm responsible for coordinating the fiber-related activities of the project. The problem that I will be talking about today is one that many of us might have experienced as consumers or as end users of a telecommunication network. Whenever we have tried to change a broadband provider, a landline broadband provider, or move from a traditional copper cable to an all-fiber network, one question that we are asked is whether there are any vulnerable people living in our premises that are in need of telecare. And one reason why the operators ask this question is that even though traditional communication networks could power low energy devices independently of the grid, we have lost this capability with the all-fiber network, which includes no copper wires, and they can carry no power at all. So this is a problem that we're trying to address within Titan, and we investigate using or transmitting an optical power beam alongside the data signal within the same optical fiber in order to regain this capability of powering devices remotely. There are several challenges associated with doing this. For example, these challenges include the amount of power that we can transmit and harvest. What is the reach that we can, the maximum reach that we can have this application working at? And this relates to the wavelength of operation of the power feed as well. And of course, the question on whether the data will be affected by the presence of the power signal. And this is an important question that excludes single mode fibers from from being used for this application, because nonlinear effects would prevent us from doing that. You can use multimode fibers that have a larger core size, but in that case, you would be restricted to multimode fiber repetition data rates. So within Titan, we explore different fiber types, such as hollow core fibers, that can propagate data and power signals without them being affected from one another. Multi-core fibers that provide spatial diversity between these signals, and double-clad fibers as well that can transmit the power feed signal over a wide area in the fiber, whereas the data signal can be transmitted in a single mode link. Thanks very much.
Brilliant, thank you so much. So next up we have Professor Giddings from Bangor University. Thank you.
Hi there. So so the title of our project for the Titan is the development and field trial of real-time physical layer network security prototypes for heterogeneously converged fiber, RF and optical wireless networks. The next slide. Yep. So in terms of the problem statement, so future communication infrastructure must be secure, quantum safe, must offer secure quantum safe data transmission. So in a world where network cyber attacks are becoming more frequent and more sophisticated, we need to start moving towards physical layer security solutions. So they're becoming more and more essential for protecting the data transmission across a diverse range of network types. So our proposed solution, in this project, we'll be developing and field trialing a physical layer security prototype, which is based on our recently proposed chaotic digital filter-based physical layer security technique. So we're going to develop the prototype to TRL level 6, and we'll then demonstrate it in various network architectures based on fibers, optical wireless links, and converged fiber millimeter wave links. And we'll be able to showcase the features of the CDF technique, including its security by design, openness by design, its universal network compatibility and ease of integration into next generation networks. And we actually, for the field trials, we actually have a 57 kilometer fiber test loop. And you can see the map there where the fiber goes, and it's crossing the Menai Straits. It's going over the two bridges that's shown there. So we can actually use that in our field trialing of the prototype. Okay, and yes. So at the top here we can see the basic structure of the prototype. So it's going to be based on FPGAs for implementing the real-time DSP for both the data modulation and the encryption, and then we'll be able to test the prototypes on various types of network. So then in the lower part of the slide, you can see we've already started looking at the actual top level architecture for the DSP development. And then some of the main sort of functional blocks within the design are we need to generate a security key which controls the response of the filters. So for that, we're actually using an OFDM based key generator. So you can see at the bottom right hand corner, we generate a digital sequence which we use to control the filters, and that is based on OFDM. And then you can see on the right there, we pass our data signal through the chaotic digital filters, and the response of the filters is totally dependent on the security key. So the amplitude response, phase response is very, very sensitive to the actual security key, and then we actually update the response of the filters regularly, so that the filter is actually continuously changing. And we've already done some proof of concept experiments in our lab using offline processing, so not in real time. And we can see, I just put an example in the top right hand corner there. So you can see the unencrypted data. So we can see the QPSK and 16 QAM constellations, and then on the right, you can see once we apply the encryption with the chaotic digital filters, we get a totally distorted constellation, and you cannot, if you're an eavesdropper, you cannot recover any of the data. Okay, I think that's it. Thank you.
That's brilliant. Thank you so much. Next up, we have Professor Liu from the University of Essex. Thank you.
Thank you so much for having me. My name is Zeilong. I'm a senior lecturer, and I'm the 6th lab manager in Essex. So in Titan, our fundamental question is how to design backward compatible instead of radically new waveform, which are able to enable efficient and resilient communication for highly dynamic NGN environments. So if you look into the picture here, in the NGN scenario, where we will need to support a high mobility communication over the doubly selective channel. At the same time, we may frequently experience the loss of synchronization. So how we are going to handle it. At the same time, because of the climate change, we could have some more natural disaster, if we have any earthquake or tsunami, which could destroy our infrastructure. So in this case, how we can design our waveform such that it is highly resilient to this disaster. So within Titan, we have been looking to the physical layer security. We have studied the integration of LoRa and the OTFS, and in Reveal 6G, we have been looking to AFDM, and then in our next project, we are going to develop a complete simulator and the USRP demo. So the main advantage of the AFDM is that it can be designed to achieve the full diversity order at the same time, and it can be efficiently implemented through the minimal modification of the OFDM system. This will actually will address the major problem of the conventional OFDM system, which may suffer from very high intercarrier interference due to Doppler and CFO. Thank you.
Great, thank you so much. We've got 4 more presentations now. So next up is Professor Nakai from King's College London. Thank you.
Good morning. Thank you for having me. I am Dr. Nakai from King's College London, and we are working on secure and private information access in distributed database networks. The problem here is that we are looking at is the privacy concerns in accessing sensitive information in distributed database, which basically this database, basically what we mean is that is provided is in the hands of providers, different providers, they are distributed. And the problem is that the use cases, the reasons that we are looking at that is that such as medical data, that they are distributed and they may be used for disease control research or drug discovery research. And all of these has to be done in a way that the patient's privacy should be intact, and they are the major concern. There are other examples, like in terms of stock market, where I want to quote of the market stock. The quotes are all public domain, but the one that I want to hide from the different servers here, because the servers could be malicious. They could contact to a connection with one another. Other important is the financial record. There are billions of payments over the year, and this information should be protected. They are distributed among different banks. Or another example is the map research. Map is a public data, but the direction that I want to hide from the servers, and also private data mining, perhaps going back to the medical data, perhaps we want to find some statistical information about how the future, how this disease outbreak new diseases may outbreak in future, but at the same time, the privacy of patients are the major concern. In terms of, so all of these basically is the challenges, brings challenges in terms of cybersecurity, which is basically protecting from malicious use of services. So what are on stake is that, in terms of relevance, that is that privacy violation and data breaches to in industries or in government sectors, they may lead to financial penalties, reputational damage, etc., and also, more importantly, public distrust. So what we are looking at here in terms of solving these, facing these challenges, is that considering the impact of the quantum computing, which is coming, quantum computing, when they come, become the serious important matter in future, is that what kind of impact the quantum computer has in terms of malicious use of services. So this is the something that we are looking at here, and I put here basically we have some services here, and these databases are public domain, and they are in the multi-user setting. Basically, everyone can use it. At the same time, so for instance, we want to have some private query to some database here, but I want to hide my the index that I want to access to that from the servers. So this is how basic comes under the important problem of private information access. Another thing that we can look at here is the, which is important, can have basically use cases in machine learning, and is the function secret sharing. So for instance, there are some function which is secret, and that has to be shared among distributed servers. These servers basically are entangled to one another. They have no relation with they are no connection with one another. So these functions should be decomposed into pieces, and then so that each server can work on that without knowing, having any information about the function, but in a way that if we add their outputs, the user can get here the value of that function in a way that these servers have no idea about that, what that function was. So the setup that we are looking at here basically is in the uplink is a classical channel. The information and data shared in these servers, they are all classical, but the downlink, which is basically is going to do to give us the information and do this linear computing at the servers, basically is the computation is going to be over the air, and that is very suitable for quantum computing, which is one of the distinct and the distinct features of the quantum computing, and also in terms of efficient communication that we have in going back and forth through these servers is important, and in there basically using efficient communication in terms of super dense coding and locally decodable code, which are again this major features and distinct features of quantum computing is going to come along here. So thank you.
Great, thank you so much. So next up is Professor Hanzo from the University of Southampton. Thank you.
Well, hello and warm welcome. I've been teaching and researching here for a long time, but have had a cracking time with the Titan Consortium. It's been a fascinating journey with 44 academics and 16 universities. I am responsible for running Work Package 5 in Titan, which is related to non-terrestrial systems. And clearly this is an extremely good time to do this kind of research because it's also part of the 3GPP framework. And so I'd like to share with you really one vision and 10 open questions. So the vision is that we could potentially migrate the cell-free concept, which has been developed for terrestrial networks, also to satellite systems. So at the top left corner, you see the conventional satellite architecture where we have the inter-satellite links and providing radio coverage. The footprint is large, so the area of spectral efficiency is somewhat limited. And so the well-developed network MIMO concept could really potentially be extended to satellite networks as well. You saw at the bottom left corner, you see these little blurbs, different colors, where a number of satellites cooperate in order to support a single user potentially on the ground, or even could support a base station or a central processing unit, etc. So this is kind of a systems-oriented vision. And now, in quick succession, perhaps just 10 open questions that we are addressing at various stages of development. So to start with, obviously, we know satellites are traveling at 7,000 kilometers per second. So channel estimation is an extremely difficult problem. And we are looking at this by using predictive and machine learning. The next question is, the next open question is synchronization. And cell-free systems themselves are really rather weak in this context because it hasn't been well developed. Then the next open question would be really the design of the beamforming schemes, which you see at the right-hand side of the figure. And so there are really very potent ideas which are being explored in this consortium. And I only have time really to sort of tell you a few more acronyms, namely ISAC, Integrated Sensing and Communications, which is a potentially high-value service, Advanced Modulation and Coding. Dr. Liu is actually working on Work Package 5 with us on this project, and then the Pareto optimization of a whole platter of metrics, and finally quantum key distribution and quantum secure direct communication. So that's all I had time for. Thank you so much.
Thank you so much. Next up, we have Adrian Womfor from the University of Cambridge.
Hi there. So I work in Titan primarily in protecting our communication networks with QKD and other quantum comms. So I guess the issue really is that the anticipated arrival of quantum computers will mean that the current encryption, key distribution systems and things can be broken in the future. So there are people who've worked on interesting solutions using mathematical complexity, the so-called post-quantum cryptography, but that still relies on complexity, and although it's confident at the moment, who knows whether it will be secure in the future. So we use QKD to try and secure links, which is based on quantum mechanics and produces true random numbers which can't in the future be broken. So next. Okay, so the two things in particular that we do in Cambridge which are relevant for this is, so over quite some time we've built metropolitan scale and national scale quantum networks, for instance, connecting Cambridge and Bristol together over the UK quantum network. But we're moving on from doing things which are purely based on QKD to building networks around within Cambridge which use quantum entanglement. So we usually use polarization-based entanglement. So I'm just showing some sources and detection systems that we use there. This is very important because one thing we want to do is remove the need for the so-called trusted nodes, where keys are decrypted and hashed together before they can be retransmitted onwards in a secure manner. So if we can go to end over very long distances without the need for that, it's extremely helpful, so that you can have truly secure end-to-end links. And again, next. So the final thing we do is work on a different type of quantum key distribution that doesn't require single photons, and therefore it doesn't need the complexity and expense of single photon detectors, is much more compatible with what's done on high data rate coherent optical communication systems. And so we use the so-called continuous variable QKD, and we're moving from a lab-based demonstrator to something which is field trialable. So there's an example of one of our field trial systems in the rack there. Clearly we'll make it smaller in due course, but all of the quantum things are in a 19-inch mounting rack with computers and things around them. So that's it. Thank you.
Brilliant. Thank you so much. So the final presentation is from Dr. Chow at the University of Hertfordshire. Thank you.
Hi, thank you, everyone. Yes, and yeah, maybe I can share my screen.
I think these slides are being shared for you, actually.
Yeah. Hello, everyone.
Hi there.
Yeah, this is Pan Cao from University of Hertfordshire, and we're working on the telecom network-based positioning, sensing, and imaging, and communication. So this is integration. We will consider how to utilize telecom networks to do the positioning and tracking and imaging. So yeah, the motivation is we consider, okay, for the environment, if the GNSS signal is unavailable or denied or unreliable in the urban area, and so how can we provide the outdoor positioning and navigation service still based on the GNSS without the GNSS? And also we consider, for example, for the low altitude flying vehicles, and how we can provide accurate positioning, and also in military service, right? So potentials, so for the air and sea defense operations, and how to utilize these infrastructures from the telecom networks. So, and we proposed the integrated imaging and communication. So this is a much more advanced functions than the traditional ISAC integrated sensing and communication. That means they only provide the functions for the appearance, range, and position or the angle, these basic information. But our solution can provide these more detailed information of the objects which is helpful for the following actions to identify the targets, for example. And we have studied these networked levels. So how to utilize these different distributed access points to to access these to collect these informations in distributed way, and then do the fusion to get a complete vision of the targets. And we also consider for the drone swarms. So, for example, we consider multiple objects and how to utilize these base stations to form a shield for from the like airspace, for the airspace, to protect the airspace, and to provide the positioning, service tracking the objects, and imaging and recognition. So this is our ongoing work, and we will doing the high TRL demos, and we'll do the first field test in the next month. Okay, yeah, that's it. We also consider the how to integrate the Leo satellite signals to achieve this goal. Thank you so much.
That's great. Thank you so much. I realise we've tried to squeeze in a lot there. We are just going to have a quick break. We're running about 10 minutes over. But before we go on the break, just to say that if anyone's interested in any of the research underway there, it was really a snippet. So there's a poll now. If you could just let us know which of the projects you're interested in. We're really looking to facilitate new collaborations between new researchers or industry and research. So if you could fill that in, that would be great. We now have a 5-minute break, so if we can ask you not to leave, just mute and turn your cameras off for the moment, and we'll come back at 12:05, please. And just to say thanks again to all our speakers. That was really great. Thank you. Okay, I think we should probably start back up again as we're running behind. So welcome back. Next up, we have the panel discussion on safe and resilient infrastructure. So really we're trying to look across sort of defence, transport and national infrastructure sectors and how emerging research can help meet the challenges in those different sectors. So I'm going to welcome Anvar Tukmanov, the panel moderator, who's from BT, and our panelists. Welcome, thank you.
Hello, everyone. Thank you, Sarah. Just a quick housekeeping point. If you have any questions, just put them in the chat. And if you see a question already asked, just vote for it, and we'll try and come back to those first. Or just raise your virtual hand, and we'll try to address your question in the end. So just referring back to the beginning of the webinar, where Harold mentioned the importance of resilience in networks, I think we heard excellent examples about the technology innovations being developed within Titan. What I hoped we could do in the panel today is to look deeper into how we actually build the networks that use those technologies, and actually go deeper a little bit into those how we build those technologies themselves. So we have an excellent panel today with extensive experience in the communications infrastructure, defense, and cutting-edge research. So just before we go on before I ask panelists to introduce themselves, I lead the wireless research department within BT. My background is radio communications. My team is responsible for application of cutting-edge research to cellular and Wi-Fi networks that BT operates, and provides services to over 25 million customers. And a point relevant to today's discussion is that BT also provides the emergency services network, which is a network connecting first responders to each other and letting them communicate in life-threatening situations, supporting faster decision-making and coordinating responses. So I'm really personally very much interested in the discussion. I hope you are as well. So if I could ask the panelists to introduce themselves, but also mention quickly how network resilience comes up in their roles, to give some context. If I could start with John Spencer, DSTL.
Thanks, Anvar. So hello, everyone. I'm John from DSTL. So for those who don't know, DSTL is the Defence Science and Technology Lab, which is part of the UK Ministry of Defence. And we're tasked to deliver the science and technology research, which in my case is focused on enabling the sort of communications our armed forces will need to operate. So for us, I guess resilience is all about maintaining communication services in environments where traditional governance has broken down, where we can't rely on enforcement of good behaviours in the electromagnetic environment, and where adversaries are competing with us to deny us access to communications. Over.
Thank you, John. If I could move on to Rob.
Yes, hello. Thank you for having me. It's a pleasure to be here with you all. So I'm Rob Maunder. I'm a professor at the University of Southampton, and actually I'm in Lyrish's research group. But in addition to that, I'm also the founder and the CTO of Accelerator, which is a spin-out company that I founded 9 years ago, spun out from the university. We have about 45 people in the team. We're based in Southampton. We also have an office in California. And our focus is on developing technology that implements 5G base stations in satellites to give worldwide coverage and to support the wide variety of different devices that 5G indeed supports. We have our technology now in dozens of satellites that are in orbit today, and we've been working with Lockheed Martin to build what will be the world's first 5G base station in space when it launches at the end of this year or maybe the start of the next. Thank you.
Thanks, Rob. Could I move on to Lajos?
Right, so very briefly, I teach and research Southampton University, and I have a little fear in various aspects of classical and quantum communications. I have had an amazing ride with Rob over the past quarter of a century, despite him looking so youthful. So thank you so much.
Thanks, Lajos. And Pericles, would you like to go next?
Yes, thanks very much. Pericles Petropoulos, also from the University of Southampton, but not within Lajos's group, even though we have and we continue to work together quite closely. I'm with the Optoelectronics Research Center, and here at the ORC, I'm interested in the application of novel fiber type and technologies, and how they can improve how we use and sense our networks. I showed earlier in one of these short interventions how we can what we do to improve the resilience against power outages. This was just an example of how we can start using cables to do more than just carry data. Another example application is sensing, and because we can use the fiber cables to sense what is happening around them, and they can do quite sophisticated sensing as well. They can detect the signature of objects, and they can aid to prevention. So there are several new developments in the fiber network that offer us the potential to do things differently, and I hope that we will see many of these developments come into practice in the next few years. Thank you.
Thank you, Pericles. If I could move to Bridget.
Hello, I was about to say good morning then, but we're just over the threshold into afternoon. I'm Bridget Bigmore. I'm the CTO of UK Telecommunications Labs, and that is a national security test lab initiative sponsored by DCIT. And our job is to both secure by design on new evolving innovation and technologies, but primarily security test the near market ready implementations of technology. We're privileged to have a tier 1 representative mobile network end to end that we use for our testing. And we work in close collaboration with the UK's major operators and suppliers. Obviously, with Ericsson being one of those suppliers, we work closely with Henrik, and of course the tier 1 operators across BT and Vodafone, and some of the tier 2 operators now as well. Personally, I've been in this role for just over a year. Prior to that, I had I'll just say over 25 years. No, I won't say exactly how much over 25 years, but multiple roles across BT, starting with BT Labs and ending up in the wholesale CIO position, which placed me perfectly for that, I guess, more application focused, commercial or national security focus, rather than the innovation focus of the work that we do.
Brilliant. Thank you so much to everyone. So if we start a discussion with the needs for resilience and safety in various sectors, so taking, for instance, transport, energy, and communications themselves. So could people just provide some comments on what do they see as the resilience challenges that they get exposed to within the sectors you work in?
Perhaps if I may share a few comments here. I think that a key aspect is about ubiquitous coverage. You mentioned transport. I took a long train ride to Manchester earlier this week and struggled very much with connectivity on that journey. So I would say ubiquitous coverage is important. That implies a network of networks, because I would suggest that there's no one size fits all solution to ubiquitous coverage. And also the network of networks gives a resilience as well by allowing different means of connectivity, so you can fall back in cases where there's outages, for example.
Brilliant. So that that kind of implies the need for integration of integration and non-terrestrial networks. Would you be able to comment what are the key challenges that you experience in making that a reality? Or just before we move on to Bridget.
Okay. Yeah, so just quickly, so in the 5G standards, NTN is being standardized as a kind of bolt-on to those standards. And what we're seeing emerging as a result of that is NTN systems that are independent but integrated with TN systems. And for example, we're seeing terrestrial network operators collaborating with non-terrestrial network operators and having roaming between those different networks for their customers. But what we can expect in 6G is a much tighter integration where the connectivity is seamless and it's not roaming anymore, it's just handover between terrestrial networks and non-terrestrial networks.
Thanks. Would you like to comment, Bridget?
Yeah, I mean, I think I'd agree. We're now talking about advanced communications networks being convergence. Users just expect a single unified underlay and are agnostic of that transport underlay so long as it works. So in order to improve resilience, having a single converged technology underlay massively improves technology resilience, geographic resilience, but also within the technology, there's site resilience, there's equipment resilience, and there's traffic path resilience. So I think if you're looking at just layers 1 to 3 and you're looking at the technology underlay, the greater number of technologies that you can interoperate between, the greater resilience you get. However, the greater number of interoperability issues you have and the magnified number of attack surfaces you have when you look at security. So security and resilience, whilst also talked about hand in hand, actually have some competing objectives. So there's much to consider.
Thank you, Bridget. Could I invite John? John, you already have your hand in to chip in with your perspective on the needs.
Apologies, I'll come off mute. So, I mean, I think I also agree. I think Bridget's point around convergence and being able to access through if you like, a common network core and a common architecture and a common set of services, different trades to give you different types of resilience in different circumstances is particularly important. I mean, so for us, for defence, I mean, we tend to need to think about adaptability, so the ability to get our communications to perform in a situation which we didn't expect. If we find ourselves in conflict against a competent adversary and they're doing their job, we should be facing something we didn't expect. We need to think about diversity. So there's no single technology option which is going to cover all potential use cases. We need to consider terrestrial and non-terrestrial services. So accessing all that through a common core becomes, particularly important. And we need to think about, the agility, how fast we can switch between the different trade-offs to do the best we can in a particular scenario.
Thank you, John. Anyone else on the Pericles, please go ahead.
Yes, thank you. I think there is also quite an important design question. I'm thinking about a reliance to specific fiber paths, for example. So, of course, optical fibers can carry a large amount of data, and it might seem quite attractive to push the points at which traffic merges to a different to a point further into the network. But does this mean that we rely even more to some very high capacity links? So I think there needs to be a co-design between all parts of the network in order to address issues of over-reliance and diversity in the communication network.
Okay, thank you. So it seems like the needs for reliability and safety are quite diverse, yet they have a lot of things in common. We talked just now about ubiquity and convergence, adaptability, and diversity. But if we take a step forward in trying to think about how we build networks that address those challenges, so what are the what do you see as key technologies or key trends that would enable UK to build the resilient communications that perform in extreme situations? Perhaps could I start with come back to Rob? Maybe you could talk a bit about the URLC communication and or the aspects of satellite and terrestrial integration.
So there's a number of different architectures that are adopted for non-terrestrial networks. There's a first architecture called the transparent architecture, which is where the base stations are located in ground stations on the ground, and then the satellites behave as bent pipes. They're relays between the user devices and the ground stations. And this has been the model adopted, for example, by AST Space Mobile. But there's a trend towards a regenerative architecture, which moves the base stations onto the satellites. And by having that processing capability, that intelligence on the satellite, it enables inter-satellite links, and it enables routing of information in space. And with that comes a resilience, as well as a flexibility that allows the data from a user device back to wherever its destination is, to be routed entirely in space, and avoiding the need for it being passed from one network to another. And also you can route around outages, for example, in connections from satellites to the ground, which might be caused by bad weather effects, for example. So I'd put forward the regenerative non-terrestrial network architecture as an example of a technology that helps with these questions of security.
Sure. If I could go next to Bridget, you mentioned convergence as a key pillar of trying to make sure that the customers actually get the characteristics of service that you need. Could you elaborate a bit more on how we would actually achieve that?
Yeah, I think all technology is facing similar issues. All communications technology, we all have to overcome the latency and jitter issues. We all have to overcome the power and cooling issues, and we all have to overcome the bandwidth and the speed issues. And that's common across all communication technologies. In order to become more resilient within a technology, then you need to maximize the physical properties of the medium. So some of the presentations we had earlier from Lou about resilient waveform design, from Lahos about direct to mobile, that's about looking at the physical properties of the satellite medium, looking at things like the geographic considerations and limitations, and really maximizing the technology. But beyond that, that's only one technology, and it's only one implementation. So compatibility and interoperability across different satellite implementations and across different technologies allows a standardization so that we get a seamless switching between different devices. Likewise, compliance to best practice security. The Telecoms Security Act in the UK is world leading in terms of the depth it goes into to ensure that all technology, all communications networks are secure and resilient. So standards, looking at compatibility, interoperability, compliance to the security code of practice. And then even if you do the secure by design and the adherence to that best practice, the level of interoperability testing and the level of security testing and penetration testing just before it goes into operation can't be overlooked either. Because regardless of how much you look to secure by design, each different regional area, each different company, based on either their commercial or their national security requirements, will implement a technology in a slightly different way. So that level of scalable testing, automated testing just before you go live, really solidifies and proves the security and the resilience across all technology. So the specific answers around the physical medium and the advancement of that medium, there's better experts, and we've heard from those experts today, but the implementation of those and the interoperability of those really is where UKTL is placed in terms of application.
Okay, thank you. And where would you say we are at the moment, Bridget, with versus where we'd like to be in terms of this system-wide testing and or rather than technology testing?
I think we're in a good place between mobile and fixed, because inherently through the duration that we've had a fixed network, moving from copper to fibre has been around as long as I've been in the industry. Moving then into mobile and interoperability between mobile backhaul and fixed backhaul is great. We're at early stages with the new technology, with the direct to mobile. And at the moment, the resilience can only be called, in my view, emergency rather than part of the underlay. So I think the advances that we're driving through Titan and other of the really improve the physical medium and the inherent limitations of that medium. The more we do that, the more it becomes integrated into that seamless underlay rather than just as an emergency backup. And that's where the focus is now, obviously. And that's why, in answer to Henrik's question about 6G, there's no compelling user case for 6G if you just think about it as an evolution of 5G. There's barely user cases commercially that we've got for 5G. Yes, we've got Internet of Things, and yes, we've got autonomous devices that will drive that user case, but it won't be a mobile user case, it will be a converged user case.
Right, so it's a seamless underlay rather than emergency resilience, Bridget, right?
Yeah.
If we could move to John. John, would you like to chip in the discussion?
So I was just gonna. I'm always, and I'm just coming in on that last bit. I'm always cautious about talking about the business case of future network systems, because they're always incredibly hard to predict, and we always think about a future network in terms of things we do already. Back at the turn of the 20th century, the Royal Navy had a really good look at radios and decided there was no use case. Because it already did other things, where there was no use case really outside of defense for the internet protocol when it was designed, until suddenly there was. If the system is right, the value of a network is unlocking ideas you haven't thought of rather than making you better at the ones you already have.
So, may I comment on that one? I think you're absolutely right, John, that in an industry where more and more of the profits are going into the over-the-top service providers, and Anvar, I mean, perhaps you'll resonate with this, operators, when you're operating at the layer 3 underlay connectivity, find it harder and harder to justify investment because their revenues are falling. The over-the-top providers don't currently have any responsibility for investing in the underlay. So I think my commercial background is giving me that perspective. I would absolutely love to be in a position where we had endless funding to invest in exploratory innovation. But with my commercial background in BT, without the return on investment and the compelling user case, it always proves hard to justify the investment.
Absolutely agreed.
I absolutely resonate with Bridget, but I'm not allowed to comment too much as a moderator. Maybe at a later stage. But if I could go to Rob next. Rob, would you like to comment?
Yeah, thank you. Yeah, thank you for coming back to me on this one. I enjoy talking about business case a lot on this topic. There's a lot of wish lists for 6G, better throughput, better latency, better capacity, and so on. But I think the thing that's been overlooked in successive generations is around ubiquitous coverage. And for me, at least, I don't know how well this resonates for everyone on the call, but for me, at least, being out of good connectivity is a daily occurrence for me. I spend a lot of time on the train, but many colleagues on this call will have heard me complain about this topic in the past. And I think that if ubiquitous coverage can be cracked, it could be really quite impactful. I recently saw a webinar where they were talking about the business case for non-terrestrial networks, and people were asked, there was a survey, they asked how many people would be prepared to pay extra to have satellite connectivity, and the answer came out at about 50% or something like this. But actually, I think that satellite connectivity is not, I would suggest, not something that people want to pay for in and of itself. I think what they truly want is ubiquitous connectivity, which will involve satellites, but it also involves Wi-Fi, for example. And if there was a means for you to pay one bill to one provider, but to have connectivity when you're in the countryside from a satellite, when you're on a train from the Wi-Fi network that's on that train, when you're in a shopping centre from automatically connecting to McDonald's Wi-Fi or whatever it is. But if it was totally seamless, then behaviours would change. If you knew that you were going to have connectivity no matter where you are, no matter what you're doing, then people's behaviours change, new business models, new use cases emerge. I think that could be really impactful.
Thanks, Rob. But I can't hold myself from commenting or echoing what Bridget just said. It is all very nice, but the fixed Wi-Fi or mobile and Wi-Fi integration technologies exist, but somehow didn't make commercial traction for various reasons to do with investments and interest. But I think it's a really exciting topic, and I'm happy we brought it up. Of course, we wouldn't be able to solve it here, but before we move on to questions around quantum and satellite and infrastructure deployment, could I ask John again to maybe come back again on some aspects to do with the requirements from the commonalities between civil and defense requirements that we briefly discussed a couple of days back, if you remember?
Yeah, sure. So traditionally, defense has kind of done its own thing with communications. We've tended to work with, our own suppliers, and we've tended to work with our own specific technologies, and there are various reasons behind that. But I think for various reasons, there are forces pushing us much closer together now. Principally, it links back into the previous conversation of maintaining separate approaches becomes unaffordable, and affordability is a real question, which even I have to accept. So, I think one of the differences for defence is we are operating in environments where access to the electromagnetic spectrum, the underpinning resource for most of the things we talk about, is ungoverned and uncontested, and that means bring some very different challenges in the physical layer, very different challenges in how you manage spectrum, but that doesn't necessarily mean there have to be different technology approaches, different network approaches, for instance. I mean, one thing that's particularly important for defence, I think, is access to diverse range of carriers. So, you know, defence being, you know, an critical military function is something an adversary will, sorry, communication being a critical military function is something an adversary will target in conflict. So we have to be prepared for the eventuality that some of it will become unavailable, and have other plans. So, you know, we can't just assume that NTN will provide all our connectivity, though NTN is something we're really enthusiastic about. But we can't assume that we'll be able to do something entirely separate, because that's unaffordable. So, you know, how can we work within these standards? How can we perhaps augment them with some things which address our specific needs, but without breaking, if you like, that core sort of open modular core, you know, so that sort of open modular converged architecture by which, you know, we can manage the complexity is looking to be one of the sort of key things for us, I think.
Thank you, Rob. So basically, it's good to hear that there's also consideration of this affordability and realizability.
Yeah.
But so that kind of brings or enables sectors to try and solve the challenges that are in common. But just if we jump on to some of the technology areas we discussed in this webinar earlier. So taking, for instance, fiber infrastructure, I'm looking to Pericles. What in your research so far? What do you see? How do you see what are the key challenges in embedding the innovation? For instance, you talked about the delivering power to end users through fiber. What do you see as key challenges in implementing these innovations in operational networks?
Yeah, so of course, the fixed wire infrastructure is represents quite a large investment for operators and the owners of the network. So it is very slowly moving, inevitably. So introducing change into such networks is not very easy. So there is a role for the research community to play in this. For example, in recent years, we have an experimental fiber system in the UK, the National Dark Fiber Infrastructure, where we introduce many different innovations, and through this, we are making a more reliable case for our solutions. But also, there is a role to play from the industry as well. Some bolder steps will need to be taken from the industry. No offense, Anwar, of course, but we can all remember how slow BT was to adopt the fiber in the network, and how much they tried to push copper before they decided to do so. Another aspect that I want to mention in this regard also is, I think it has been mentioned before, that we need to make sure that any solutions that we introduce are performing very reliably as well, and they are very robust. And through our research, we are also trying to understand how we can bring back more robust solutions. And the one thing that I'm having in mind is through the introduction of hollow core fibers, for example, which will allow us to simplify our transmission systems to a certain extent. And I am interested in exploring this further. But then, of course, this will also require new fiber infrastructure to be laid on the ground in order to benefit from such advances. So I think that there is a two-way argument there. So both the industry needs to be a little bolder, perhaps, but also the researchers need to be more careful in introducing or when they introduce these new propositions.
It's music to my ears, very especially the last part. The researchers being considerate of the practical constraints. But maybe I think it was before I jump into or come back to the ways that industry and academia could collaborate better with examples from Titan. Could I go to Lajos? Lajos, would you like to comment on anything that has been said so far?
Yeah, so basically it's a diverse consortium, and we've got the other two hubs as well. So under Joiner, we have a fairly large community now, which is diverse in the sense of both looking at, looking beyond the horizon with radical new ideas, but then also we heard in the presentations that some of us go up to TRL6. And so we cannot expect that every university research group or team behaves in the same way in this, this kind of conglomerate of different universities, depending on their, lab facilities, the amount of thing they have, and so on. And the way I view this is that diversity is a good thing in general in any team. And not just preaching the eye here, but ultimately different skills. We need the innovators who come up with a bunch of new ideas which may or may not find applications for the next generation of mobile phones, even for 6G, but beyond. But then there's also those who really look at the practicalities and do their cutting-edge research on implementations. And an extremely good example how Professor took his cutting-edge research to industry and started up the company. And really the university group also benefits from this link where the dialogue supports both part of the community, and there are other similar spin-off companies from the Titan consortium. So a quick point really, because it's been fascinating listening to the different views, and this is more a technical note. Mentioned again seamless connectivity, and at some stage in our previous discourse, John mentioned using multiple technologies, for example, in order to provide that resilience. Because if we have multi-connectivity through satellite and terrestrial, for example, then outages could be minimized. Of course, there's increased security issues again, and this belongs to more frontier research, which may not find its way into BT's portfolio or any of the cellular operators' portfolio in the next couple of years. But the ideas must be ready for implementation out there, and industry can decide to define some of them and adopt as and when appropriate. So I stop here. I touched upon many different points, but it's been very interesting to hear views from this fairly diverse population of the panel.
Thank you, Lajos. I think that's a really nice summary of the discussion we had so far. But just with an eye on the time and trying to leave some time for questions, could I ask the panelists just maybe to comment on, based on the webinar so far, what do you see as key barriers between this ability to build the right system, as John put it, to actually getting out there in some sort of proof of concept that Pericles alluded to by using the dark fiber facility, if I name it correctly. So could you just maybe quickly comment on what can be done to enhance the collaboration between academia and industry towards better impact for resilience? Rob, would you like to go first?
Sure. I think if I can draw upon my own personal experience over the last 9 years, through the spin-out journey, it's taken me that many years for engaging with the stakeholders of my research to become something that was outside my comfort zone to become something that's inside my comfort zone. But now having appreciated it and adopted it as a key part of my approach to research, I find that engaging with the stakeholders enormously valuable. And there is sometimes a criticism of academic research, which is that it finds a solution and then searches for a problem for it to solve second. I think the thing I would encourage all academic colleagues to do is find the stakeholders of your research, engage with them, really understand what the problems are that truly exist for real people, and then focus on solving those problems. Problem first, solution second, rather than the other way around.
Thank you, Rob. Bridget, would you like to go next, please?
Yeah, just reflecting on your out of comfort zone, Rob, I am in that right now. I left academia over 30 years ago. I've had a commercial focus during that period, and here I am back in the hollowed halls of Cambridge, faced with multiple experts deep diving on the technology. So thank you for having me. But I mean, it'll be no surprise to you that let me just say my background. I came into a commercial environment through BT Labs, and BT Labs was as close as you could get at the time I joined it to an academic environment. The number of patents, the blue sky research, the amount that we had to invest then in what might become a commercial or a national security offering later on was far, far superior to what the operators have got now. And I am grateful and thankful that that was my upbringing. Over the last decade within BT, that environment has changed significantly. So I think, echoing what you said, Rob, getting really close to your stakeholders across government and across industry, understanding the problems that they are trying to solve, using a prototype or a proof of concept. Don't wait until it's perfect. Anything that might work can be tailored jointly with the customer for something that will work for the most immediate need. And I think that targeted investment in what they need now. Also, I think with one eye on what Harold said at the start of this conference, having an idea and having that concept of how society will change and what drivers will have in the future. Because if you tie down the investment to just what we need today, you'll kill innovation. If you go to the other extreme and you just scattergun your investment across what could be the future, then you'll run out of money. So there's that tipping point between understanding your customers' requirements today, but having one eye on the societal changes, so you're not limiting that innovation of the future.
Thanks, Bridget. Pericles?
I resonate fully with what Rob and Bridget have just said. And I find also Bridget's comment on the chat quite interesting as well. And I wonder, I don't have the answer, but I wonder what the industry can, or what we can do to help the industry take these bolder steps. Because, and coming back to that example of how late BT decided to adopt a fiber network. Of course, the cost of implementation was too high, but we know relatively to what other countries in Europe have done, for example, how this has slowed down development in the UK. So what can we do in order to help the industry make bolder steps?
Thank you, Pericles. John?
So I guess the challenge for me, and perhaps echoing what others have said, is how do we pay for it? What's the sustainable business model for a 6G communications infrastructure that includes the resilience properties that we need for national security and defence, because at the moment we've got some really exciting activities like this one. So there's a national focus from DCIT and in defence to uplift our our connectivity game, but that's got to leave behind a sustainable market, and that's not all going to come from subscribers. So our business model, I noticed comments in the chat about whether telecoms is a utility and so on, that these are questions we're going to need to solve, and I'm not going to do now.
Thank you, John. Maybe a tiny bit later.
Yeah.
Right. Could I go to Lajos? Lajos, would you like to comment a bit more on how academia and research could work better together?
Yeah, so I think, again, there was, well, probably over a decade ago, an article by one of Cambridge's vice chancellors as to how it's possible that in the US there's so much interaction between academia and industry, and this is to a lesser extent true for the UK. I think right now this is improving, and again, Rob's example and Harald's example are extremely good in this context. I think really universities ought to give the academics autonomy in this respect, and so Southampton really did well, and I think also Harald benefited from this probably, but there must be awareness which helps entrepreneurs to really roll out their ideas into SMEs and then eventually into products, but it also still requires that vital linkage between the blue sky-ish new ideas. Often they start with a patent, like in Rob's case, it was this wonderful fully parallel turbo decoder, which then kickstarted his company basically, and now he's got a huge portfolio of patents. But we also know that these are expensive, so one missing kind of component was identified by this vice chancellor, namely, the venture capital in the UK is less readily available than in the US. But again, this is just the way I see it, and I guess there is no engineer who wouldn't like to have their own little laboratory in industry, their own company, but it requires the right environment, the right support.
Great. Well, at this point, I'd like to thank the panelists for a lovely discussion. Now, looking at the questions in the chat, I think the suggestion to vote for the questions didn't actually work because they're not sorted. So I can't. There are lots of questions, which is great, lots of discussion. But perhaps with an eye on the time, I'd like just to pick up maybe one question that I see right now in front of me, and if people want to ask any question, please raise your hands in the meantime. So Mustafa is asking about do you see any meaningful opportunities to evolve channel coding using AI in future communication systems to improve resilience, or do you think resilience is more a matter of network design and resource management with limited influence from coding techniques? If I could just paraphrase this question a tiny bit, if we could just think about AI and the role of AI in resilience, because we all know there are good benefits from these new these technologies, but again, explainability is a challenge. Would anybody want to comment on that? How do we handle AI in for resilience? Rob, would you like to go first?
Well, if you don't mind, I'll give an answer specifically to that point about channel coding, which is one that is very close to my heart. I think back to the way that the 5G channel code was standardized in 3GPP. I was present at each of those meetings, and sometimes they went on till 2 o'clock in the morning until consensus could be agreed across the companies present. But actually, the way that the channel code was defined is actually quite surprising. It's specified by a big matrix of numbers. And essentially, the way it came down in the end was that company A contributed this row of that matrix and company B contributed that row of that matrix. And it was just piecemeal put together with different rows come up with different companies. And there wasn't really a holistic optimization of the design. That's not to say the design isn't a good one, and the 5G channel codes have been very successful. But there's clearly an opportunity to have some AI to design holistically channel codes, and indeed that, you know, there's lots of examples of big matrices of numbers being designed and placed in the standards in various different places where AI could be used to design the standards. How you get different companies to coordinate on that, I'm not so sure. And then there's a question of how you might use AI in real time in the operation of a physical layer, for example. I think there's a place for that in channel estimation and equalization and so on. I'm not so convinced that there's the same opportunity for that in error correction, particularly in places where we need very, very low block error rates. You know, AI, I think, can design codes that can do well 90% of the time, 95% of the time. But when you're looking for 5 or 6 nines reliability, I would suspect that at least for the time being, the traditional methods might be the key there.
Thank you, Rob. Bridget?
Yeah, so my answer is less specific to channel codes and more to the way that we're using AI with our security testing. Less generative, more augmental AI, and looking at how machine learning can help with analysis of network state, configurations, common false problems, anomalies that would help us to identify somebody that's snooping or changing configurations or profiles or the network. So with augmental AI, it helps us to monitor, troubleshoot and repair based on known states, and machine learning about how additional products and additional services and new ways of using the network change those states. I would add the proviso that all AI is based on the integrity of its large language model. And if that integrity is poor, then it does limit the effectiveness. But we're already there in use of AI.
Thank you, Bridget. And Lajos, would you like to go next?
Oh, Bridget, you stole my line.
Oh, I'm sorry.
No, just kidding. But
was it the last bit? Was it the large language?
It was so beautifully put. Again, I sort of concur with you and Rob, because AI is good in the face of uncertainty, but when we have good models, when we have extreme specifications, lack of explainability, etc., is a problem. But coming back to a very specific point Rob made, one of our former colleagues just visited us last week from Canada, and they are also using ChatGPT to design quantum codes, for example. So for the design, yes. For like decoding, it's impossible to beat the existing model-based algorithms. Thank you.
Thank you, Lajos. I think at this point we are running out of time, and I'll hand over back to Sarah. Again, thank you so much for the panel. It's a really good discussion.
Yeah, thank you. Yeah, just thank you so much, Anvar, and all the panelists and all the speakers today. Just to Harold's messaged in the chat just to send his apologies. He had another meeting that he had to go to, so I'll close this session today. There was just a couple of points that I wanted to follow up on. Firstly, just around the collaboration piece. So that's really what this event and Titan are. It's one of their real key objectives, is to bring those different stakeholders together. So, you know, have the researchers there, but connect up with government and industry as well. So sort of next steps from this event, we are going to contact people that have responded to one of our polls and follow up with perhaps some one-to-one meetings or working groups. We're not entirely sure yet, but we will have a tangible outcome from this meeting. So that was really nice to hear you all sort of talk about the importance of that. The second point was one of Leos's comments around investment into research and venture capital. So the federated telecoms hubs, all of which Titan is one, is really looking to connect up the investor and VC world with the research. And I'm going to put a blog in the chat that we've just published this morning, so you can have a little read about what we're trying to do there. Pericles, did you have a comment?
Yes, in your previous point, I've mentioned to Srinjoy that unfortunately our project on power over fiber was not included in the poll. So if anyone was interested in that, I would be happy to follow up.
Yeah, please do. In fact, Srinjoy, if you can just make a note of the project in the chat, and if anyone can just like it, that will indicate, yeah, that would be great. Thank you. Okay, so I think that sort of wraps up for today. Just again, a huge thank you. Unless there's any more questions or comments, I'll just say a huge thanks from Titan and Professor Haas, and everyone can go and enjoy the rest of their Friday. Thank you very much. Take care.
Thank you.
Bye-bye.
Thank you.
Bye.
Bye. Thank you.